Hello, space enthusiasts. Get ready for an exciting journey to explore the universe beyond our planet Earth. In this video, we'll be covering everything that exists outside our planet, starting from the closest stars to the farthest reaches of the universe. But hold on, we won't be covering Earth itself because, let's face it, Earth is so complex it requires a video, or maybe even a series of its own. Instead, we'll start by exploring our solar system and its fascinating planets, moons, asteroids, and comets. After we've explored the solar system, we'll head out to the nearby stars and star clusters in our galaxy. We'll be discussing the different types of stars, including the giants and the dwarfs, and all the incredible objects that can be found within our Milky Way galaxy, such as black holes, brown dwarfs, and nebulae. After this, you'll know what a galaxy contains, and that means you know what every galaxy contains because every galaxy is the same fundamentally with slight variations. Next up, we'll take a look at the nearby galaxies and the amazing structures they contain. From there, we'll head out to galaxy clusters and superclusters, some of the largest structures in the universe. Finally, we'll explore the cosmic web, the largest structure of all, and see how the universe is connected in ways we could never have imagined. So buckle up, because we're about to embark on an incredible journey through the wonders of the universe. It's going to be out of this world. Before we begin, let me clarify that this video will provide a brief overview of the solar system, including the sun, planets, moons, asteroids, and comets. We will not delve deeply into each one as separate videos will explore them in detail. Our focus today is to take you on a journey beyond Earth and explore the wonders of the universe. Let's start our journey with the center of our solar system, the mighty Sun. This fiery ball of gas is the most massive object in our solar system, with a diameter of 1.39 million kilometers, which is more than 109 times larger than Earth. The Sun is a powerful star that emits light, heat, and energy that enable life on Earth to thrive. We humans have studied the Sun extensively by space missions such as the Solar and Heliospheric Observatory, or SOHO, the Solar Dynamics Observatory, or SDO, and the Parker Solar Probe. Now let's move on to the first planet in our solar system, Mercury. It's the smallest planet in our solar system, and it's also the closest to the Sun. Mercury's surface is covered in craters and is often described as resembling our Moon's surface. Mercury has been visited by only two spacecraft, Mariner 10 in 1974 and Messenger in 2008. Next up, we have Venus, a planet often referred to as Earth's sister planet due to its similar size and composition. Venus has a thick atmosphere that traps heat, making it the hottest planet in our solar system. It's also the only planet to rotate clockwise, opposite to the other planets. The hottest planet in our solar system has had quite a few visits, with a total of 20 missions, including the recent Parker Solar Probe and Bepi-Colombo missions. Now, we'll skip Earth for obvious reasons and move on to its companion, the Moon. This celestial body has been a fascination for humanity for centuries and plays a vital role in stabilizing Earth's rotation and ocean tides. Let's move on to the red planet, Mars, which is the fourth planet from the Sun. Mars is often called the red planet because of its rusty red appearance, and it's known for its two moons, Phobos and Deimos. It has been the most explored planet in our solar system, with a total of 60 missions, including rovers such as Curiosity and Perseverance, as well as orbiters like Mars Reconnaissance Orbiter and Mars Express. Mars' two moons, Phobos and Deimos, have also been studied by several missions. As we travel beyond Mars, we come across the asteroid belt, a region between Mars and Jupiter that contains millions of small and large asteroids. The largest object in the asteroid belt is Ceres, a dwarf planet that makes up more than 1/3 of the belt's total mass. Ceres was studied by the Dawn spacecraft in 2015. Other asteroids in the belt have been visited by various missions, including Hayabusa 2, OSIRIS-REx, and Near-Shoemaker. Now let's move on to the gas giants, the outer planets in our solar system. First up, we have Jupiter, the largest planet in our solar system, with a diameter of over 142,000 kilometers. Jupiter has a complex system of more than 80 moons, with four largest known as the Galilean moons. which are Io, Europa, Ganymede, and Callisto. These 4 moons are some of the most studied moons in our solar system due to their unique and diverse characteristics. Io is the most volcanically active object in our solar system, with over 400 active volcanoes that constantly reshape its surface. Europa is believed to have a subsurface ocean that could potentially harbor life, while Ganymede is the largest moon in our solar system and is the only moon known to have its own magnetic field. Callisto, on the other hand, is believed to be one of the oldest objects in our solar system, with a surface that has remained relatively unchanged for billions of years. Aside from these 4 large moons, the rest of Jupiter's moons are much smaller and have irregular shapes. Many of these moons are believed to have been captured asteroids or comets that were pulled in by Jupiter's immense gravity. Despite their strange shapes and sizes, these moons continue to fascinate scientists and astronomers, offering new insights into the complex and diverse nature of our solar system. Jupiter has had 14 missions, including the famous Galileo spacecraft and the Juno mission currently in orbit. Moving on to Saturn, it's the 6th planet from the Sun and is known for its iconic rings, which are made up of ice and rock particles. Saturn has more than 80 moons, with Titan being the largest. Titan is a unique moon that has a thick atmosphere, rivers and lakes of liquid methane and ethane, and a subsurface ocean of water. The other major moons of Saturn include Enceladus, which has a geologically active surface with plumes of water vapor and ice particles erupting from its south pole; Mimas, which has a massive crater that gives it a resemblance to the Death Star from Star Wars; and Rhea, which has a heavily cratered surface and a tenuous atmosphere of oxygen and carbon dioxide. Most of Saturn's moons are irregularly shaped and thought to be captured asteroids or fragments of larger objects that were shattered in collisions. Saturn has had 9 missions, including the Cassini spacecraft that studied the planet, its rings, and moons for 13 years. Uranus, the 7th planet from the Sun, is known for its unique tilt, which causes its poles to face the Sun. Uranus has at least 27 moons. The 5 largest moons are Miranda, Ariel, Umbriel, Titania, and Oberon. Miranda is the smallest of the 5 and is notable for its unusual surface features, including cliffs as tall as 20 kilometers. Ariel has a heavily cratered surface and distinct grooves, while Umbriel is known for its dark surface and cratered terrain. Titania is the largest of Uranus's moons and has a relatively smooth surface with few craters, while Oberon has a heavily cratered surface and is believed to have a subsurface ocean. Uranus have been visited by only one mission, Voyager 2, which provided us with the first and only close-up views of these distant planets. Finally, we have Neptune, the 8th and farthest planet from the Sun. Neptune is a gas giant and has 14 known moons. The largest moon of Neptune is Triton, which is the 7th largest moon in the solar system. Triton is unique in that it is the only large moon in the solar system that orbits its planet in a retrograde direction, opposite to Neptune's rotation. Triton is also geologically active, with features such as geysers spewing nitrogen gas and a surface that appears to be relatively young. Other notable moons of Neptune include Nereid, which has a highly elongated and tilted orbit, and Proteus, which is the 2nd largest moon of Neptune and one of the largest irregularly shaped bodies in the solar system. Like Uranus's moons, many of Neptune's moons are irregularly shaped and small. Neptune also have been visited by only one mission, the same mission which studied Uranus, Voyager 2. This one mission provided us with close-ups of both Uranus and Neptune. Beyond Neptune, we find the dwarf planet Pluto, which was once considered the 9th planet. Along with Pluto, other celestial bodies like Makemake and Eris are located in the Kuiper Belt. Pluto had its first and only flyby by the New Horizons spacecraft in 2015, providing us with stunning images of the dwarf planet and its moons. Pluto has 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon is the largest and most well-known of these moons, with a diameter about half that of Pluto. The other 4 moons are much smaller, with diameters ranging from just a few kilometers to a few hundred kilometers. These moons are thought to have formed from the debris of a collision between Pluto and another large object in the Kuiper Belt, a region beyond Neptune that is home to many small, icy bodies. Other missions to the outer solar system include Pioneer 10 and 11, Voyager 1 and 2, and the recently launched Lucy and Europa Clipper missions. That's a quick overview of the solar system. As we travel farther into space, we'll come across even more wonders of the universe. So stay with us and let's explore the cosmos together. As we leave the familiarity of our solar system behind, we enter the vast expanse of interstellar space. Beyond the reach of our sun's gravity lie countless other stars, each with their own unique characteristics and mysteries waiting to be explored. The journey ahead will take us to the closest stars to our own, shedding light on the nature of these distant suns and offering a glimpse into the wonders that lie beyond. Let's now journey out into the cosmos to explore the stars that surround us. The stars nearest to our sun are Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Alpha Centauri A and B are actually a binary star system, meaning they orbit around a common center of mass. Together, they are slightly farther from us than Proxima Centauri, but they are still relatively close in astronomical terms, at just over 4 light-years away. It is also the nearest star to our solar system, and it has received quite a bit of attention from astronomers in recent years due to the possibility that it may have an Earth-like planet in its habitable zone. While these 3 stars are the closest to our solar system, there are many other stars in our Milky Way galaxy that are relatively nearby as well. After the Alpha Centauri system and Proxima Centauri, the next closest star to our solar system is Barnard's star, which is about 5.9 light-years away. Another nearby star is Wolf 359, which is about 7.8 light-years away. The next 5 closest stars to us after Wolf 359 are Lalande 21185, a red dwarf star located about 8.3 light-years away from us; Sirius A and B, a binary star system consisting of a main sequence star, Sirius A, and a white dwarf, Sirius B, located about 8.6 light-years away from us; Lyton 726, 8A and B, a binary star system consisting of 2 red dwarf stars located about 8.7 light-years away from us; Ross 154, a red dwarf star located about 9.7 light-years away from us; Ross 248, a red dwarf star located about 10.3 light-years away from us. Despite their proximity, these stars are still incredibly far away and would take thousands of years to reach with current technology. However, advances in space exploration and technology may one day allow us to travel to these stars and explore their systems more closely. Before we move on to exploring galaxies, let's take a closer look at what else is out there in the vastness of space. We've already seen some of the closest stars to us, but within a galaxy, there are many other types of objects that are just as fascinating. First up, we have brown dwarfs and red dwarfs. These are both types of stars that are smaller and cooler than our sun. Brown dwarfs are sometimes called failed stars because they don't have enough mass to ignite nuclear fusion in their cores. Red dwarfs, on the other hand, are the most common type of star in our galaxy and can live for trillions of years. Next, we have black holes, which are incredibly dense objects that form when a massive star collapses in on itself. They have such strong gravitational pull that not even light can escape, making them invisible to the naked eye. Neutron stars and pulsars are also incredibly dense objects that form when massive stars explode in a supernova. Neutron stars are so dense that a sugar cube-sized piece of matter from one would weigh about as much as all the people on Earth combined. Pulsars are a type of neutron star that emits beams of radiation that can be detected on Earth. White dwarfs are another type of star, which are the remnants of stars like our sun that have exhausted all their fuel and collapsed in on themselves. They are incredibly dense and are about the size of Earth. There are also many other types of stars in our galaxy, such as blue giants, yellow giants, and supergiants, which are much larger and brighter than our sun. Supernovae are explosions that occur when massive stars run out of fuel and collapse in on themselves. They can briefly outshine entire galaxies and are some of the most energetic events in the universe. Gamma-ray bursts are another incredibly energetic event that occur when massive stars explode in a supernova. They release massive amounts of energy in the form of gamma rays and are some of the most powerful events in the universe. Quasars are some of the brightest and most distant objects in the universe. They are powered by supermassive black holes at the centers of galaxies and can outshine entire galaxies. Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. It doesn't interact with light, so it's invisible, but we can detect its effects on the motion of stars and galaxies. Dark energy is an even more mysterious substance that makes up about 68% of the total energy in the universe. It's causing the expansion of the universe to accelerate, but we don't yet understand what it is. Exoplanets are fascinating objects that have only recently been discovered by astronomers. They offer a glimpse into the possibility of other habitable worlds outside our solar system and the potential for extraterrestrial life. These planets can have a variety of compositions, from solid rocky surfaces to thick atmospheres of gas and even oceans. Some exoplanets even orbit their host stars in the habitable zone, where temperatures are just right for liquid water to exist on the planet's surface, a key factor in supporting life as we know it. The study of exoplanets is a rapidly growing field in astronomy and holds great promise for uncovering the mysteries of our universe. Now that we've explored some of the fascinating objects within our galaxy, it's time to take a step back and look at the bigger picture. In this section, we'll learn about the Milky Way and other nearby galaxies that are part of our cosmic neighborhood. The Milky Way is a barred spiral galaxy that contains an estimated 400 billion stars, along with vast clouds of gas and dust. Our solar system is located on one of the spiral arms, about 25,000 light-years from the galactic center. The Milky Way is about 100,000 light-years in diameter, making it one of the larger galaxies in the local group. It's thought to have formed around 13.6 billion years ago, shortly after the Big Bang. The galaxy's spiral arms are populated with many young, bright stars, as well as massive clouds of gas and dust that give rise to new stars. At the center of the Milky Way is a supermassive black hole, which is estimated to have a mass of around 4 million times that of the Sun. This black hole is surrounded by a dense cluster of stars that are gravitationally bound to it. Now that we've explored our own galaxy, let's take a look at some of the other galaxies in our cosmic neighborhood. The closest galaxy to us is the Canis Major Dwarf Galaxy, which is about 25,000 light-years away from us. Despite its name, it's actually a small, irregular galaxy that's only about 7,000 light-years in diameter. Scientists estimate that it contains about 1 billion stars. Moving further out, we come to the Large Magellanic Cloud, a dwarf galaxy that's located about 160,000 light-years away from us. It's a satellite galaxy of the Milky Way and contains about 10 billion stars. Next up, we have the Small Magellanic Cloud, another dwarf galaxy that's located about 200,000 light-years away from us. It's smaller than the LMC, with a diameter of about 7,000 light-years and contains about 7 billion stars. Moving even further out, we come to the Andromeda Galaxy, which is about 2.5 million light-years away from us. It's a spiral galaxy, similar in shape to our Milky Way, and contains an estimated 1 trillion stars. Finally, we have the Triangulum Galaxy, which is about 3 million light-years away from us. It's a smaller spiral galaxy that's often overlooked because of its proximity to the much larger Andromeda Galaxy. The Triangulum Galaxy contains about 40 billion stars and is an important target for astronomers studying the evolution of galaxies. Moving further out, we encounter the Virgo Cluster, a cluster of galaxies located about 54 million light-years away. It contains over 1,000 galaxies, including elliptical and spiral galaxies. Even further out, there's the Coma Cluster, a massive cluster of over 1,000 galaxies located about 320 million light-years away. Beyond the Coma Cluster, there are even larger structures known as superclusters, which are clusters of galaxy clusters. These superclusters can span over hundreds of millions of light-years, and they appear to be interconnected by massive filaments of gas and dark matter. The Virgo supercluster is one of the most massive and closest superclusters to our Milky Way galaxy, containing approximately 100 galaxy groups and clusters, including the Local Group and the Virgo cluster. It has a diameter of about 110 million light-years. One of the largest known superclusters is the Laniakea supercluster, which contains over 100,000 galaxies and has a diameter of roughly 520 million light-years. However, the Laniakea supercluster is just a small part of an even larger structure known as the cosmic web, which is a network of interconnected filaments and voids that span the entire observable universe. The largest known structure in the observable universe is the Hercules Corona Borealis Great Wall, which is a massive galaxy filament that measures around 10 billion light-years across. The universe is a fascinating and complex place, with an incredible variety of objects and phenomena at all scales. From the smallest particles to the largest structures, we see the same fundamental laws of nature at work, producing a rich tapestry of cosmic wonders. All right, guys, that's it for today. Subscribe to stick around. See you next time!